Swayam Prabha. Digital India. Educated India.
Hello. Hello, welcome students to the live session. So this is the last and final live session before the exams set on 16th of November. So we had gone through the forum and found that there are some clarifications requested, particularly in the marking scheme for MCQ answers where partial answer is correct. So let us clarify that if it is partially correct, you will get some marks, but if it is partially correct and you are ticking on some incorrect option, then it will be treated as totally incorrect. So you won't be given any marks even if you have given tick to one right answer, one of the right answers. So be careful, be confident that it is a multiple choice answer and you only tick on which you are confident. If you are ticking any other which is wrong, you will get totally no marks. But if you are confident on a partial answer, you will get some marks. I hope it is clear to you. Now again another question has come in as a last year query in calculation of absorption. Suppose some alpha value is given. Do we need to consider the floor absorption also? So here it is quite obvious that it will be a space where some furniture, things, people will be sitting. So sound will be interrupted by those furnitures even if something we consider is getting reflected from the floor. So in most of the cases the sound is, we are not considering the floor, but yes, for foot sound, to avoid noise, we do some floor treatment in some special cases, say in a conference room where you require total silence. So if someone is coming in with some boot sound or some shoe sound, it's better to put a light carpet over there. So it is not mandatory to consider floor, but depending on the space you can consider. Mostly we do not consider the floor absorption or the floor reflection in the entire process of calculation. You have any question?
So I have 4 such questions which came in our forum. The first one is the clarification regarding assignment 6, question number 7, related to lecture 27, positive and negative dB, alternate side of the axis in the question. Yes, it was a mistake in the question number 7 and assignment 6 we have noted down and the marks will be given accordingly. Both the cases it has to be minus 6 dB and minus 6 dB. So that was a printing error. The second one is that the mismatch between the lecture 33 slide 6 where it is mentioned as a phase should coincident effect versus the answer of the assignment 7 question number 2, the frequency should be coincident by Amit Kakkar. So this has also, I think we have addressed in the forum, but still I will mention the thing is that that particular slide talks about the coincidence effect, which actually talks about the phase of the incident sound wave when it is matches with the barrier, the phase of the barrier, and also the natural frequency of the barrier and the incident frequency of the sound wave. Both has to be matched together. So out of these two, as the particular barrier doesn't have any phase, and the matching of the frequency, natural frequency and the incident frequency has to be similar like, then the coincident effect will be there. So if you go to that particular slide and if you listen the lecture, it may not be properly mentioned in the lecture, but if you go through the my narrations and all, you will find out that this frequency also plays a major role. So the question number 2 of assignment 7 stand as it is, there is no change, and the option P was correct for that. We have mentioned also in our forum. Then there are two questions as a homework point of view. So, first one is the how the directivity and the polar plots of a loudspeaker are related. See, if I go to that particular slide, I think it is in the yes. If you see the directivity index is the actually if I go a little earlier, yes, here. So, the just in front of the loudspeaker, if you take any particular radius r and at particular point you are measuring the I average and the L average, and if you go angular displacement some other angle theta, this I theta and the L theta will be maybe some different value or maybe the same value. Mostly it will be different value. So, the ratio between these two are the other directivity factors. So, the intensity of the sound and the level of the sound will be high at this particular point, and similar high frequency may occur little lower radial distance, may not be at exactly same radial distance, may be here. So, now if I plot this and then maybe another distance like this, so I will get a smooth plot of having iso L, and that is going to be the polar curve. So, if I go to the next, you see if you go to the next now, what are those lines? Those lines, if this is the the level, so you will won't get the same level at this particular point. You will get the same level little near to the center, closer to that. So, now if you plot, so that will give you the polar plot. So, from that directivity and the polar plot are related to that way. That is number one question, and another one is the question that somebody has asked that IIC, that is the impact insulation class, how to be calculated, which is also one of the lecture 35. Lecture 35 it is there, but it is actually I have broadly discussed about the, if you go to the lecture 33 STC. It is very, if you understood the STC character, it is very similar to that. We have the 1/3 octave band, and we actually examine, if you go to the earlier one, the impact bond sound. So, there is a impact tapping machine which will give some kind of impact, and from the impact you will find out the suppose this one. Suppose this one, this is a particular some flooring. So, if you tap at this particular point and then you receive some amount of sound intensity, and based on that how much is the transmission loss, you plot for each and every 1/3 frequency, and then you go as a contour we do it for the STC, and from the frequency of the 500 frequency you draw the line, and then we will get the corresponding the dB transmission loss, and that is the IIC. So, if you remember the STC, why this smooth straight line is there, because anyway you will get some haphazard point, and we will smoothen that point based on the curve fitting and based on some kind of reduction and all that. You can go through the lecture 33, and the similar way STC is calculated, the similar way IIC is also calculated. The another question we got, which is a very interesting question. Okay, we can move to that. Yes.
To the live questions. It's only measure.
What instrument used for acoustical measurement? Acoustical measurement, basically we use the dB meter, that or some analyzer. dB meter is a simple instrument that can used to measure the decibel level of various points of a inside a room or maybe outside also. And analyzer or some other instrument which is requires some kind of software or also the monitor to analyze the various frequency and its different dB, corresponding dB.
Okay.
This is from B.K. Subhadra.
So I think we have no more questions.
We
We
discuss.
can discuss it.
So another question came where the particular student has mentioned that regarding the impedance, it was discussed in the lecture number 5 by Professor S. Bhattacharya, where it is mentioned that impedance equal to medium density into sound wave velocity. And in lecture 11 by Professor Gupta, where it is mentioned that the impedance is equal to pressure by velocity. Yes, both are correct. And the second one, the impedance equal to pressure by velocity, is actually noted as a specific acoustical impedance, and here you have to see that there are this velocity is actually the particle velocity. See, if you see sound wave is a kind of a wave where the particle velocity and the pressure is fluctuating, and there is a displacement, and there is a displacement amplitude also. So this velocity, which comes out to be pressure versus by velocity, is your dy dx or dy dx of your the total motion. So if you know the equation, that is y equal to a sin omega t. So you have to find out the dy, here t is the x axis, so dy dt, and that is the velocity, that particular velocity you have to consider. In the first equation in the lecture 5, whatever is given is the sound wave velocity, that is the velocity of the wave, which is 330 to 340 meter per second. It is fluctuate because of the temperature and other issues. And the medium density, basically it is the medium density is the air as a density. So that this is the two difference between these two concept of the impedance, acoustical impedance.
So all the questions
Yes.
are over, and I think there was one more question. In critical distance formula, what is Q and how do we calculate Q? So this was a last year query and was not addressed in lecture video. I think no, it was addressed. Critical distance was in, actually the Q metric was separately discussed, and then while finding out the critical distance, it was applied over there. So Q metric was applied, and it is told that Q metric has to be 1. Q metric is the energy of the signal divided by the energy of the signal plus the early reflection, and divided by the late energy from the late reflection and the energy of the noise. And it is told that Q has to be minimum of 1 for acoustical quality, to achieve acoustical quality. And for particularly for classrooms, for primary section and all, Q, more the higher the value of Q, better it is, and maximum you can achieve up to 4. So Q metric is considered as 4 in the calculation. If you go to the lecture on classroom, I think it is here. Yes, here it is. You can see you are taking Q as 4. So RC is given by root over under root Q into R divided by 16 pi, where Q is the Q metric, which is maximum of 4, which has been considered in this case, and R is the room constant. Room constant is also given in the slide, as it is the total absorption in a room, including the air absorption in metric 7. So when you have these values from charts, you can find out the critical distance wherefrom you are not getting or receiving direct sound, or it is very low, and you are only depending, the hearing is only dependent on the early reflected sound. So that is the significance of Q metric. So higher is the Q metric, and you can achieve maximum up to 4. In an environment there is always some late reflection and some noise, so you can get 4 maximum of Q. And for classroom design, particularly for children who are in the age of formation of their senses, they are actually, to achieve intelligibility of 100%, you require a high Q value. So Q is a metric similar to that of RT. Like reverberation time, we say you have to have a live room, you have to have a dead room or a medium dead room. Similarly, Q metric is also a measure where you actually find out what is the signal ratio of the signal to that of the noise. So we are looking forward for some more questions. We are presently over with the questions which we thought would be of interest to you, which were raised in earlier session, and also some were queries which we wanted to clarify because it is time for the exams. And if you are ready with some questions, you can please send it. এখানে কি বলা যায় 25% from the assignments ওগুলো বলা they know is it circulated that 25% of the questions from assignments they know, isn't it?
No more questions, huh?
ছোট বাজে কটা ঘড়িটা কোনটা ঠিক when did we start? 15 minutes. It's just 15 minutes done. আরো 15 minutes at least we have to see. We can discuss like
the question এগুলো খালি এন্ড সেমিস্টার একটা কাম করো এন্ড সেমিস্টার exam pattern
yes exam pattern MCQ type তাই না so for those who are there in the session in the live session and also for those who will be appearing for the examination, so we found the number of total registered number, it is quite promising, so we are getting a good response from you all. So for the mostly it is the multiple choice questions and you also have numerical type questions, but in some cases you have to type out the answers. Isn't it? No, we don't have typing. Okay, so you have to tick the answer, tick the correct answer after calculating it out. So you will have the options and you have to tick it. Once it is, if you tick it correctly, you get the full marks. And again I repeat, for the partial and partially correct answers, if you are putting any tick on a wrong alternative, you are going to get totally discredited. If you are putting one partial correct answer, then you will get partial credit. But so be very careful and be confident before you put the tick or the cross. We have around 40% of the questions as numerical. We have around 40% of the marks dedicated to numerical type questions. So you have the online calculator also, so you can calculate it out in the online calculator. I think many of the questions means a part we are supposed to give from the regular assignments which you have already done. So you will get some familiar questions, you may get some numerical questions where some values will be changed. So you practice the assignment questions, homework questions given to you, and I hope that will give you enough confidence to do away with the numerical types. Go through the lectures regularly, at least before the exams you at least go twice, thrice, so that the lectures you keep on remembering the theories where from you can actually give the answer. Remember, it is all the principles which will be giving you the answers. We are not going to give you any question where it will be you have to guess and give the answer. So you have to, if you know or if you have a good understanding of the whole thing, you will be able to answer most of the questions correctly.
I will suggest you go through all the 8 assignment once again. And as you know that some 15% or some percentage will be from the assignment, but rest of the questions will be very similar to the assignment question, maybe from some different concept, may not be the exactly same. But if you go through the assignments and particular PPT and all, then you will be able to answer the end sum question and you will score well.
এটা দেখিস এতজন রেজিস্টার করেছে আগের বার কত ছিল আগের বার it was around like this I am civil engineer Which topic?
The subject.
Subject. So are you doing the course? Is he a registered student? So why did you pick up the course? That is my first question. I hope you took it either of interest, either it is of interest to you, or you are finding you hope you will find some application in your work. But civil engineering, he is asking whether it is relevant to civil engineering course
this
or
course
not.
is basically designed for the architect, but definitely civil engineering students can benefit it from this course. See, the thing is that you have to understand the something that a architect actually going to design the building, and when he design the building he conceives some space, and that space has to be altered to a space where the acoustics is very important. It may be a classroom, it may be a studio, it may be auditorium. Then some consultant he will pick up for hiring for the acoustical consultant, he will go to that electroacoustics and all. But if an architect knows the subject better, then when he actually conceives the design, he will definitely do the things better, and there should be a good dialogue between the consultant and the architect. Yes, civil engineers is also going to be commissioning that particular space as a contractor or maybe designer in other aspect, structural design also. So it is good to know about those aspects of architectural acoustics also for them. So I should not say that it is immaterial also, but definitely some of the civil engineers I have came across, they have a good understanding of the architectural things and all. So definitely it will help you in future.
Actually, if you are doing some industrial design as a civil engineer, there will be noise. So
Yes.
how to create the barrier? That noise will be a disturbance to the other people. So if you know this subject, you will be careful. Maybe you will be more careful, or maybe more looking into the human aspects, like how it may disturb. Because in that environment, one person has to work for say 30 years. So if that is a disturbance to his, perpetual disturbance for him, it may be a very bad space design. So maybe in an industry, it is not an architect is not hired, rather civil engineers are hired for the entire plan design. So there, if you keep that in mind, it will be of importance.
See, I will just give you one small example. In our IIT, we know that we two are from IIT Kharagpur. In our IIT, we have a department called Civil Construction and Management. So recently we are doing a auditorium in our Calcutta center. So things are actually checked and commissioning by our civil engineers. So they time to time come to us and verify some of the things. But if they has to take some then and there some decision, so that particular knowledge is required.
Yes.
Of that particular acoustics knowledge and all these things are required. So from that point of view, definitely civil engineers also can learn this subject and all. And what madam has just now said, if you go to the last module of our this thing, I mean where the environmental acoustics has been given, so that is very in lieu with your environmental engineering. Some of the environmental engineering is actually deal with the water pollution, air pollution, also sound pollution. So some of the things are along with that. So that is also going to help you in that way.
Yes. What are the requirements to set up acoustic material testing laboratory? Ranjit, the question from Ranjit that has come. So, frankly speaking, we do not have such testing laboratory, but you require some anechoic condition to test some materials acoustical property. So, anechoic chamber, if you go, it is a kind of dead room, completely dead room. Actually, then only you can measure the particular characteristic of the building by whatever instrument you target. So, you will require an anechoic chamber and the material and the gadget by which you are going to test the characteristic or the acoustical characteristic of the material. Maybe you are calculating alpha value at different frequencies. So, you have to give that particular sound, emit that sound that will be received by the material, how much gets absorbed, how much comes out. So, that kind of environment you can, that kind of testing is maybe done in such chambers, but unfortunately we do not have in our department. In our institute there is a provision for there is a anechoic chamber, but we have never looked into whether we can go and do some material testing or not. I think Professor Bhattacharya, would you like to add something?
See, mostly there are two ways of testing lab. One is the testing materials, what madam has just now said, you need an anechoic chamber, and from there you have to test it by varying different panel and sound frequency and get those sound level calculations and all. But another aspect of this thing is that you on live or on site you sometimes measure that, suppose the auditorium is already in use or maybe going to be used. So, there you go and then you test with maybe a empty auditorium, what is the reversion time, where is the sound focusing much, where is the sound is not that much, or which particular band of frequency going to be break in some point or so. Mostly that is taken care of by the sound engineers also. Architects doesn't have that role to play, or the consultant initially do it in the simulation. Nowadays there are a lot of packages are available, so simulation, and from that they understand the scenario and then do some few tests in the site. But testing lab for the panels and all, what madam has said, we have to have that kind of a chamber.
Half an hour. I think. How many are there? You told 4 are waiting. Only they are listening. They are only listening. I think we can say some. Okay. How can I set up such lab is the question. So you have to visit some lab and get the input, and then accordingly you have to make the requisition or the purchase, and then you have to assemble them, and then you can start with such kind of laboratory. I think you can any approval required if you are talking from some institute as a faculty or something, your institute has to pass. I don't think you require any other special permission. Do we need acoustical permission for setting up? No, not like that. But your institution should be there is no hazard in this. So it is not a fire, you are not doing any flame test or something. So I hope you don't require, and you are not making very high level noise also. So, if you are making such things, then you have
You
to
can
take permission.
actually, if you want to set up in your, I don't know, you are a faculty or so, hope you are a faculty, and if you are want to set up, if I will suggest you to visit CBRI Roorkee, they have a not very good, big but small acoustical lab, I heard. I have not also visited, I have visited their other lab also, maybe. You go and visit that particular acoustical testing lab, and then you can take decision.
Another is you can even visit some hospitals have, say, where you need to check your ear. There also there are anechoic chambers. You can have a feel of what it is. It is not very heavy, means it's not financially also very heavy, but you have to buy the instruments and create that anechoic space, which is a little means not difficult but specialized, which you have to ask technicians to create that kind of environment, and then you have to give the sound and that check. It is done in hospitals where the ear treatment is done. So, there are chambers where particularly they are kept as an isolated room, and there the patient is taken, and the doctor who is treating actually gives some impulse, that is speaks some sensible words, and they try to find out the patient is in an enclosed space, and they try to see what the patient is responding at different sound levels and at different types of sound. So, there they do the testing and find out which kind of impairment is there in the ear, and suggest for some medical aid, that is hearing aid, so that he or she gets a correction in hearing. Okay, so you can experience that as a first hand, or else what sir has suggested, you can go to CBRI, and you can also look for in the net what kind of setups are there internationally or maybe in other parts of the country, and I think there are very good laboratories. And what is the purpose, that is also very important. If it is only academic and only testing few materials, then you can always do it.
You also set up private lab.
Oh.
No. Then also you can visit.
Private lab. Yeah, then in that case we would suggest you should visit few number of labs and then finalize. Private lab and approval, see, if you are having some private lab, for what purpose? So, is it a commercial purpose? Then you will require such commercial license. How do we know what is the purpose? If it is academic purpose, you need institutional sanctions. But if it is a commercial setup, say if you bring out products with particular after particular testing, or you do a testing laboratory, then you will require, it is for a commercial purpose, then you will require different kind of sanction from the local municipality, local authority. But I hope it is a green industry, even if she is thinking at a industry level. Commercial. Now it is coming commercial. So, as I already understood that it is for commercial purpose, then you have to get sanctions on that particular line. So, industries, whether it is an industry, whether you are going to bring in product or doing some testing, depending on that you will require those sanctions.
I don't think you will require any kind of a sanction from the pollution board or fire or those kind of things. Fire, definitely if you want to set up a lab, you definitely need some that building permission or something.
Would be relevant, he has to.
If you are in a city, you talk to the corporation people or the municipality people, that what are the nominal permission required for set up a building. I mean, there is nothing special for that.
I think we have fewer questions. We are having no more questions. I think we close the session. So if you are quiet on that side, I think it's time to close the session, and all the best, our best wishes to you all.